right. Hello, everyone. Welcome to our very first live community call. We're extremely excited to share with you some of the latest updates and news about our product, OpenReplay, as well as to discuss some interesting tech with our guest speaker here. But before we move on, in case you're hearing about OpenReplay for the first time, just know that it's an open source session replay tool which allows you to reproduce backs found by your users, support them live, and monitor your application's performance. With that said, let's get started with today's agenda. We'll first go over some of the latest product updates by our CEO, Mehdi Osman. We'll then move on to show you a quick glimpse at our backend architecture with Rashesh Rashendraj, who's the man in charge of our DevOps operation. We'll cover different aspects of our architecture on every call to help you understand how things work out. And finally, we'll jump into Mark's Volkmann's laptop to learn about Svelte. So without further ado, please, Mehdi, take it away.
Hi, thanks, Fernando. I'm very excited. I've been waiting for that for a long time, and I cannot wait to tell you more about what we've been up to at OpenReplay. So my name is Mehdi Osman. I'm the founder of OpenReplay. And today I'm going to be showing you the different updates we've got and what's going to come next. So starting from version 1.5.0, we've been working very hard on the session replay part. And a big thank you for the community, first of all, for your love, and then for all the feedback we've got. We know you face a lot of frustration sometimes, finding that needle in the haystack, jumping to an issue inside a very long session replay. And so we've been working on that. And one big thing is we've been redesigning the session replay page, which is going to come out pretty soon over the coming weeks. But for now, what we decided to do is just to focus on the low-hanging fruit. So we've added pagination. So when going back and forth between the sessions list and the replay, you can still find that the last session that you've played. We've added metadata on cards. So now you can see all of those keys and values that you've been sending alongside your session replays right there from the list. And now it's possible to save your search, right? And you don't have to go through the funnels anymore to do that. So whatever events or filters you're using, it's a click away to save those and then get back to that list of sessions and share it with the rest of the team. With the assist, and just a quick reminder about what assist is. It started as a cool feature that we wanted to implement at some point in time, I think last summer. And we've seen a tremendous growth on that part. So assist is a way to see your end users browsing your website live and engage with them. Now, what we've been doing recently is we have rewritten that from scratch, making sure that this can scale up to thousands and tens of thousands of concurrent sessions. And we've added even more capabilities to it. So we've taken remote control to the next level by adding annotations and the support of keyboard typing. Analytics. So analytics, this is that metrics section you can see on the top right of the header. And well, we've been proposing a few widgets. Well, to be precise, a bit more than 40 different widgets about key performance metrics, and that would go from things like time to render to time to visualize, to memory consumption, to CPU, etc. But we wanted to make it as simple as possible at the very beginning when we started that by just allowing our users to simply add or remove a widget. Now, obviously, you couldn't leverage the data and the different events and filters we were capturing. And this is why we decided to introduce custom metrics. So custom metrics is a way of building your own charts and picking any event or filter from that list. So if your goal is to simply focus and monitor a JavaScript errors that are happening on a specific page, well, you can do it with custom metrics today. If you want to just keep an eye on those frustrations and click ratios, they're happening only in one part of your funnel, where you can do that with custom metrics. That wasn't possible before. So this is something that we have introduced very recently, and I'm super happy to talk about it today. All right, OmniSearch. We added network payloads. So now you can search not only by URLs and calls, but you can also search by HTTP status. You can search by payloads in general. And again, like the goal is to find that needle in the haystack. And we have slightly improved the autocomplete flow by optimizing few queries here and there. All right, now what's coming next? Again, we are on a quest regarding the session replay to find, report, and fix all those small frustrations there. And so that we've been going through a redesign that you will be seeing very soon, but also we've been optimizing all of the queries that separate you from clicking on the play button and seeing actually the session replay. So obviously by clicking on that button, there is a list of events that has to be loaded, the metadata, the network, the inspector in general, and then the file that contains the session replay. Well, we've been reviewing all of that so that loading time would be at least 3 times faster than before. You'll see that coming up and coming out by end of this week. Analytics. We're still continuing on building on top of those custom metrics. And so we will be introducing dashboards. So you could create your own views and share it with the rest of the team so you can collaborate and keep an eye on what matters the most for your business. On the DevOps part, we have moved from a plain Nginx implementation to Kube's ingress controller to benefit from the sticky sessions, the auto-renewal of certificates, and much more. And we're using now Cert Manager. So again, we're making even the deployments, even on the Community Edition, much simpler than before. So you don't need to run that cert bot script every 3 months to renew your certificate. Now, all of that will be taken care of automatically by the installation. Before passing the mic to Rajesh, I would like to give a word or two about our license. And as you may have noticed, we have switched licenses recently and moved to Elastic V2 from MIT. And I think we've been extremely transparent from day one, from the day we open sourced this entire project back in June last year. Our philosophy is that if you're an individual contributor, a small team, or a startup, you need to have access to that forever free Community Edition and have full control over your data. But if you are an organization or a big corporation in general, they're like, we're helping you, like we're giving you a ton of value with Session Replay. Well, we think we should and we must monetize it. Today, if we want to keep this project sustainable and we invest in our community and in our product, we have to monetize it. This has to be through a sustainable business model. We are a VC-funded company, and this is extremely important for us. So without getting into some of the bits that you may heard of about, what happened to Elastic and Redis and Mongo and how they changed their licenses over the past year or two, where we're trying to do that today and future-proof our product. We've seen some signals from big players, mainly major cloud providers, and we thought that would be the best time to do that move. Now, what would that change to you if you're a user or a contributor? Well, first of all, if you're a contributor, we still have that contributor license agreement, so that doesn't change anything. You can still contribute and build stuff on top of it. And if you are a user, well, most likely that wouldn't change anything. Elastic V2 is a non-copyleft license. So you can still use, copy, distribute, modify, and use it in for your commercial business. So that doesn't change anything. But Elastic comes with 2 or 3 limitations, and we make that super clear. The first one and the main one for us would be you cannot offer OpenReplay as a managed service. In other words, you cannot compete with us. And this is what we're trying to protect ourselves against. You cannot circumvent license keys that are protecting some of our proprietary code. And I'm thinking about the enterprise features that we're using today to monetize the project. And then last, well, you cannot hide or obfuscate notices, copyright, and other licenses that you might find on the repo. But apart from that, what I love about Elastic, especially the V2 license, is you don't need a lawyer to go through all of those terms and conditions. It's pretty simple. You can understand it, you can read it, and we make it very clear about the limitations. Other than that, you can do whatever you want with it, and it's still fully open. All right. Without further ado, I'm going to be passing the mic to Rajesh. So Rajesh is leading our DevOps efforts here, and he's going to be giving you an overlook and an introduction to our backend. Rajesh.
Yeah, hey. So today we'll have a look at our architecture. So we thought it will be a very good start point to start with our architecture, which will give a bird's eye view of how OpenReplay works. So all of our components, as you have noticed, is running inside Kubernetes because we are following microservice architecture. That means we have some of the components which are written in Go, some of the components written in Python, some of the components is the remaining stuff are in Node.js. So we have mainly three components. One is our proxy, which is Nginx. Second one is our worker layer, which is all the components who is doing the OpenReplay work. And the third one is our event stream engine, that is Redis or Kafka. So once a session ingest comes in, for example, when a tracker event starts, so that tracker event will origin a request to Nginx. That request will pass on to the HTTP worker. What HTTP worker does is it will take all the requests, do a bunch of processing, and then put the data into the event stream topic. There will be other workers will be consuming that particular topic, and for example, sync will consuming to that particular topic, and when there is an event comes in, sync will consume that event, do a processing, which means to convert that data into file chunks and store the data into NFS. Once the session ended means it can be idle timeout or the user close the tab. Either of that, once the session ended, that will generate another event by the ender worker along with other functionalities. That ender worker will generate an event and put it into that topic in the event stream. That will be consumed by the storage layer. What storage layer does is storage layer check for all the data, the file chunks data related to that ended session, and compress all those session data and put it into the menu or the S3. It can be any S3 compatible API storage, which we are using for the long-term storage. So that is the life cycle of an ingested session. Now, when you are going to replay a session, basically we have another layer called Chalice. Chalice is our API engine who is backing most of our front-end functionalities. So Chalice will communicate with the S3 backend and generate a signed URL and pass it along to the front-end browser with which you will be replaying the session. While replaying the session, you might have seen there is another sidebar which will be giving you a lot of derived metrics like the click events and then the URLs, all those things. So those metrics are generated by our ender itself, along, as I told, along with other functionalities. One of the functionalities generating these metrics, and then you will see all the data in the front end. Then we have alerts. Alerts is nothing but when you are generating an alert in the front end. For example, when you're saying that, okay, hey, I need to have an alert when these particular event occurs. That event can be, say, JavaScript error or 404s or something like that. When something like that happens, when you need an alert is the guy who is triggering the alert. Then we have assets. What assets does is cache all the CSS components. Why we are caching the CSS components is, for example, after an year, when you want to replay a session, you won't have the same CSS when at that particular time, right? You will have revised that CSS multiple times and you won't have the same CSS. So we will cache that asset in the sense CSS, HTML, or whatever it is. We will cache the entire thing and they'll put it into the backend storage, which is S3. So that when you're replaying, you can see the same session as it was at that particular point of time. Then we have the DB worker. What DB worker does is, DB worker is the guy who take all the derived metrics from events and then put it into the DB database. That can be either ClickHouse or Postgres. Yeah, so they will put it into that particular database. Then we have other worker, which is called assist. As Mehdi told, assist is a big feature in OpenReplay now, where you can directly interact with your end user in live session. So how assist work is, whenever you are seeing all the live sessions and trying to join into a live session, that will trigger a request to assist worker by Nginx. That will create a WebSocket. So what that WebSocket does is it will create a connection between your browser and your agent's browser, and you will have a direct connection between these two. That is handled by assist, which is powered by Socket.io. And then you have another option to call the user. Call the user means you have a button to either voice call or a video call to interact with the user. That feature is powered by Peers. Peers is another worker who is using WebRTC to generate all these calls. Okay, so I hope till now I am very clear. This is the overview, the bird's eye view of OpenReplay, the architecture, the Kubernetes, the components, the front end, the back end. So if you have any doubts or any discussions to make, please feel free to join our Discord server where our community is very active. Yeah, that's a hello overview. Thank you, Fernando.
All right. Thank you, Rajesh, for the overview. This is a very interesting topic and one that we'll definitely keep exploring in future calls. As a side note, if there is any specific subject someone in the community or in this call or watching this video wants us to cover as part of these calls, please reach us out on Discord, as Rajesh mentioned, and let us know. And so we'll add it into the next community call. And speaking of reaching out, we've had such a good reception of our Svelte articles on our blog that we decided to ask Mark Volkmann, author of Svelte and Zapper in Action, to come in and discuss the topic even further. So let me just quickly pull him back in to the stream. It's all you, Mark. Take it away.
All right, ready to go. Yeah, so I'm excited to talk about Svelte today, and in particular, I want to focus on the parts of Svelte that give reactivity, and I'll explain exactly what I mean by that. As Fernando said, I'm the author of the book Svelte and Zapper in Action, and I've been a software developer for a long time. I do a lot of writing, especially on my blog that you can find at that URL there. I've worked with many web frameworks, including AngularJS, Angular 2 and beyond, React, Vue, and now Svelte. And so I feel like I'm in a good position to compare all of these things. So Svelte is an alternative to all of those other frameworks, and it's a compiler, not a runtime library. And I'll talk more in just a bit about why it's so important that Svelte is a compiler. You can use JavaScript or TypeScript with Svelte, and it was created by Rich Harris, and he is also the author of some open source libraries called Reactive and Rollup. You might have heard of probably Rollup. And he did work in the graphics departments at The Guardian and the New York Times, where he had the requirement to develop graphics for those websites quickly. And so that really influenced his design of Svelte to make it something that you can work with and implement something fast. Now, Rich is employed at Vercel, where he's being paid to develop Svelte full-time, which is good news for the Svelte community. So some of the benefits you get from using Svelte, one is that you write less code to do the same things that you might do in other frameworks. For many people, that alone is enough of a reason to choose Svelte, but there are many other nice features. One is that your components are implemented in a single source file that includes all the JavaScript, HTML, and CSS used by that component. That CSS is scoped by default, and so you don't have to worry, for example, that if you want a button to have a red background in this one component, that's going to accidentally bleed over to some other component. It's all scoped to that component. And what we want to focus on today is the reactivity part. And there's kind of two pieces to think about here. One is, how do you manage the state within a single instance of a component? And the second is, how do you manage state that would be shared across components and keep that in sync across them? And we'll look at both of those in the slides coming up here. one of the approaches that you can use inside a component is called reactive statements. And it's a bit like a formula in a spreadsheet. And we'll see some examples of that as well. And then Svelte offers two-way data binding. And most often you'll see this in a context like you want to bind a variable to the value of some input so that if the user types something into that input, that will change the value of the variable. Or if your code changes the value of the variable, what's displayed in the input will change. It goes in both directions. Svelte provides a lot of built-in animations, and so you typically don't need to pull in a library to add animations to your code. You just use what Svelte provides. Svelte produces really small bundle sizes, and one of the reasons for this is that the Svelte compiler can look at what you've written and determine what parts of Svelte you're actually using and only include those parts. And so that contributes to faster startup times because there's less to download to the browser. And one place where that comes into play is with animations. So there's a lot of animations provided out of the box, but when you deploy your code, it's only including the animation code that you're actually using, not every animation that the library supports. So why is it important that Svelte is a compiler and not just a library? Well, there are a lot of things that being a compiler enables, and one of those is eliminating the use of a virtual DOM. When you think about the way a virtual DOM works, there's a lot of overhead there. So what you need to do to have a virtual DOM is create an in-memory representation of what you want to render on the screen. And then after changes are made in your application, it can create a brand new in-memory version of what you now want to display. And then it has to compare those and find out what really changed and try to minimize the updates to the actual DOM. All that is great, but there's a lot of code that is behind that. The code to build the virtual DOM, the code to diff them and see what has changed. None of that has to be shipped if your approach doesn't use a virtual DOM. And that's one of the benefits of Svelte, is that it doesn't need that. I'll talk about why that is in just a second. Being a compiler means that you can support some custom syntaxes, and Svelte components are implemented inside a .svelte file. It's not a JavaScript or a TypeScript file, although it includes JavaScript or TypeScript inside it. But the fact that it's a .svelte file means that it can support custom syntaxes. The compiler is reading that and interpreting some things maybe in a different way than it would be if it was straight up JavaScript. One example of that is the reactive statements that I mentioned on the previous slide. Being a compiler means that it can look at what you're doing in your code and detect if there's some CSS that you're not using, which is great because that can be highlighted in your editor or your IDE, and you know to clean that up and get rid of the parts that you're not actually using. And then the last thing I want to point out is that it can optimize the JavaScript that it's producing because it has a view of everything that is used in your application. And so it only includes the parts of the Svelte framework that you're actually using. So thinking about these benefits of being a compiler leads you to the conclusion that if there are good ideas in Svelte, other frameworks like, say, React and Vue, they can't just copy those ideas because they don't use a compiler. And you have to be a compiler to have the benefits that I've talked about here. So it's a big deal that Svelte is a compiler. So this is what a .svelte file looks like. There are 4 sections, all of which are optional. The first section is really rarely used, but that's there if you want to have class level kinds of things. So for example, maybe you want to write some utility functions that you'd like to export so that other components can use them. And that's a place where you can put that code. But as I said, that first script tag with a context of module is really rarely used. Then you have the JavaScript that is the implementation of this component. And one of the main things that you'll see there is this export syntax. And this is a place where the Svelte compiler takes what is standard JavaScript syntax and interprets it in a different way. In a .svelte file, this export means that you're declaring a prop. This is data that another component can pass into this component. And so in this case, I'm expecting a name to be passed in. And you see in the HTML that follows, that third section, I've got an H1 element, And then I want to display the value of name, and I put that in curly braces. That's called an interpolation. So in that section, I can have any HTML I'd like. And then finally, there's a style section where I place the CSS that is going to be automatically scoped to this component. So as I said earlier, all of these parts are optional. So you could, for example, only have the HTML, and maybe you don't need any dynamic data, and it would just render some static content. So focusing on reactivity, the big story here is that top-level variables in a Svelte component are the state of that component if it's used in the HTML. So in this case, my script tag just declares a single variable count initialized to 0. And you see that down in the HTML bit, I have an h1 tag that is using an interpolation to display the value of the count. And so that means that count is part of the state of this component. And better yet, if my code makes a change to that variable, my component will automatically update to show me the new value. And so I have two buttons. There's one button with a minus on it and one button with a plus on it. And if I click those, different things happen. In the case of the first button, I want it to be disabled if my count goes down to 0, because I don't want you to make it a negative number. And so that's the disabled attribute. And then there's an on click. So this is how event handling works inside of Svelte. And so I'm passing to on click, in this case, an arrow function, an anonymous function. And what I want to do when the button is clicked is just decrement the value of count. And so that alone, just decrementing the value of count, is going to cause the HTML on the next line to get updated because the value of count changed. Likewise, the second button, when it's clicked, increments the value of count. And so that will also cause the h1 content to be re-rendered. So looking at this simple example, I think it's useful if you've been working in some other web frameworks to ask yourself, what code would you write to do this same thing in your framework? I'm very confident that regardless of what other framework you might be using, it will take more code to do this than what you're seeing here. And this is one of the appealing factors of Svelte, is that you can get things done in a really small amount of code. And the code that you have is pretty easy to understand. There is one kind of gotcha when it comes to reactivity in Svelte, and that is when you're updating an array. And that's because if you add an element to an array or remove an element or just change the value of an element at a certain index, you're not really changing the array. It's still the same array in memory, and Svelte doesn't recognize that you've done that. And so for Svelte to know that you've made a change to an array, you have a few choices. One is to create a brand new array where you essentially make a copy of the previous array and then make your modification to it. And that's what I'm doing on that first line where I'm calling concat. I'm adding an element to the end of an existing array. But unlike push, concat actually produces a new array. And so if I assign that back into the same variable, my ARR, well, now Svelte is going to see that I've made that change. And if I'm using that array in my HTML, it'll know to update that. Another thing I could do is use the spread operator. That's just a different syntax, though, for creating a new array. Finally, I still can use push, but then I have to remember to assign that variable back to itself. And so the end of that last line there looks a little bit odd. You're not used to assigning a variable to itself. But that's enough to tell the Svelte compiler, hey, I really am making a change here. And so if I'm using this in the HTML, you really ought to re-render that part. So while that syntax looks odd, it's actually the most efficient because you're not making a copy of the array. The Svelte REPL is an online tool that you can use for experimenting with Svelte components. It's a great learning tool. You don't have to install anything to use it. And when you use this, it can show you the JavaScript code that the Svelte compiler generates for you. And it can show you the CSS that is generated so that you can have a peek behind the scenes and understand how it is that that CSS is getting scoped to the component. You can also save a session that you've created in the REPL so that you can come back to it later. And so over time, you can build up a collection of examples that you find interesting and be able to revisit them to refresh your memory. You can also export one of your sessions so that you have the files locally on your machine, and then you can continue developing in your editor of choice, like say VS Code. So I've got lots of examples that I have saved in REPLs, and so I've got a URL there to my blog. And so if you click on the Svelte category, inside that is REPLs, and that page contains a bunch of links to interesting REPLs that you might want to check out. So I mentioned reactive statements earlier, and this is an interesting bit of Svelte because it requires some custom syntax. You see in all the examples at the bottom that they begin with $:, and that's a marker for a reactive statement. So if you think about this in terms of JavaScript, it's just a label whose name happens to be a $, because labels in JavaScript are some name followed by a colon. But Svelte is interpreting labels to mean something a bit different. Inside a .svelte file, that $: syntax means this is a reactive statement. And it's very much like a formula in a spreadsheet. So for example, if you were working in a spreadsheet, you might be used to seeing things like equals B3 plus C3. And you know, that means go find the number that is in the cell B3 and then add that to the number in the cell C3 and take that result and put it into the current cell where this formula is. So these reactive statements are very much like that. You can read them as saying, if anything I'm referencing in this line of code changes, I want to re-execute this line of code. And so in my first example, let's assume that scores is an array of numbers. And anytime that array changes, I want to add up all the numbers in that array and place the result into the variable total. So if I'm trying to display total inside my HTML, I would just put that in curly braces. And then I know that if some bit of my JavaScript code updates the scores array, that's going to update automatically because total in this case is part of the state of my component. The second line is interesting from a debugging standpoint because that says if the value of total ever changes, please print it out again in the DevTools console. The third line, I'm calling a function evaluate cart, and I'm passing it a cart that is presumably an object that describes all the items that I want to purchase. I'm also passing in tax rate. And so if the cart contents change or the tax rate changes, I'm going to call evaluate cart. And supposedly evaluate cart is modifying some other state variables that I'm then going to display within my HTML. And then finally, the most general thing you can do is include an entire block of code after the $:. And then anything I'm referencing in that block of code, if it changes, it means I'm going to re-execute this block again. That can be lots of lines of code, but as you can imagine, it's easier to maintain this code if you keep some limit on how much code you place in this kind of a block. Maybe keeping it under 10 lines of code is a good idea. So with that knowledge in hand, we can take a look at what I find to be a very compelling example of using reactive statements in Svelte, and that is creating a user interface that computes monthly payments on a loan. And so I want to allow the user to enter in a loan amount, an interest rate, and a number of years for the loan. And then I'm going to calculate what the monthly payments will be and display that at the bottom. So I'm going to flip over to a REPL session where I have implemented this, and it's right here. And let's take a look at how this actually works. And so you see on the right, the user interface produced by this bit of code. And let's start at the top and look at some variables that I'm working with. And so I've got interest rate starting out with a value of 3, a loan amount starting out at 200,000, and a number of years starting out as 30. And then I've got this constant, there are 12 months in a year. So just with that bit, if we scroll to the bottom and look at what I'm displaying in the HTML, I've got a label for loan amount, and then there's an input with a type of number. And then this bind : value piece. This means I want a two-way binding between the variable loan amount and this input. And so that means if I change what is in this loan amount, it's going to update this variable. The same thing for interest rate. It's going to start out showing me 3 because that's what the initial value of the interest rate variable is. But if I change the input, it's going to update the variable. The same thing for years. And then finally at the bottom, I'm going to display the calculated payment to 2 decimal places. But we haven't seen yet the code that calculates the payment. So if I go back up to lines 7 through 14, these are all my reactive statements. Remember, what's happening here is that if anything referenced in the reactive statement changes, it means I want to calculate that or re-execute that bit of code. So looking at the first one, months per year is a constant, so that's not going to change, but the number of years could change. And so if I go into my user interface and I change the years to 29, then that would cause line 7 to re-execute. And I now have a new value for the variable months. But if I look a bit further down, I see that months is used in line 10. So if months changes, then I'm going to have to recalculate this value of denominator. If I change the loan amount, then that's going to cause line 9 to re-execute and recompute the value of numerator. And if I change the interest rate, that's going to cause line 8 to run again, and I'm going to recompute the monthly interest rate. But if monthly interest rate changes, that's going to trigger line 9 as well, and I'll recalculate the numerator. And then we go down to the most important line, line 11, where I'm computing the payment. And there are a bunch of possibilities here. So one is that I don't have a loan amount. If I just change the loan amount to 0 or I delete that value from the input, then this part is going to run. And I can't calculate this without a loan amount. And so I'll just use the value 0. Or if you haven't told me the number of years of the loan, then I can't compute it. And so I'll just set it to 0. But if it's not one of those two cases, then I come down to the next line and I'm asking, do you have an interest rate? If there's no interest being charged on this loan, then I can just take the numerator and divide by the denominator, and that will give me the result. I said that a bit backwards. Line 13 says, do you have an interest rate? If I do have an interest rate, then I want to divide numerator by denominator. But if I don't have an interest rate, well, then the payment is just the loan amount divided by the months. There's no interest involved, and so it's a very straightforward calculation. But in the case that I have an interest rate, well, there's a very specific calculation I have to do, and I won't dive into the details of this, but if you look up how to compute a loan in some kind of a finance book, you'll find exactly this formula. So one of the things that's really great about this approach, other than that there's very little code here, is thinking about when does something get recomputed. If you were to rewrite this example in other frameworks, you would likely end up with a situation where all it can do is detect that something has changed. And because something has changed, it would run through all of these calculations again. And then you ask yourself, well, what's going to be re-rendered when something changes? And then the answer will be all of this below is going to be re-rendered. But in the Svelte case, that's not true. So suppose that the only thing that I change is the number of months. Let's see. Let me think through this a second. Let's go with interest rate. So all I change is the interest rate, and I change it from 3% to 4%. So I just did that. And so looking at line 7, this line is not going to run because interest rate doesn't affect that line. But I did change the monthly interest rate, so that's going to trigger line 9 to run, and also triggers line 10, and then that's going to trigger the payment. So in this example, you could say that I'm not really saving that much. All I did was skip rerunning line 7. But in other examples, this might be significant. You really only want to do the work that is required and not just blindly re-execute all the computations in your app. I mentioned also thinking about what is being re-rendered. So if I change the interest rate, what has to be re-rendered? Well, it's only this monthly payment bit right here. And so Svelte is smart enough to generate JavaScript code that intelligently re-renders only the bits that are required to re-render because some value that they're using changed. And so it's better for JavaScript calculations, and it's better for DOM updates, that it can very quickly know what parts need to be updated. It doesn't need to generate a full virtual DOM of the whole thing and then compare it to a previous one to see what changed. It knows in the generated code that line 27 only needs to re-render if the value for payment changes. So I think this is a pretty compelling example of how reactivity works in Svelte and the benefit of using these reactive statements. Another piece to talk about is how Svelte deals with state that goes across components. And so for that, Svelte provides a thing called stores. This is a publish-subscribe mechanism, and there are 4 kinds of stores that you can create. There are writable stores, where any component can pull the store in and make changes to its value. There are readable stores that components can pull in to get their value, but they can't change the value. There are derived stores that combine data from multiple other stores to compute a value. And then custom stores, where you're in control of the API for making changes to the data. By far, the most common kind of store is a writable store. But one thing I should point out about readable stores is that it doesn't mean that the data never changes. It just means that the components can't change it. And so what happens in this case is that the store itself is implemented perhaps to periodically reach out to data sources to get updates. So a readable store could, for example, every 5 minutes make a call to a REST service and grab the latest data and update itself. And then the components would just be displaying the latest data. But I want to focus here on writable stores. So the easiest approach you can take is to define all your stores in a file that might be named stores.js. And so then all of your components can import any stores they care about from that file. Subscribing to a store is done by just preceding its name with a $sign. There's an explicit way that you can say you want to subscribe, and then an explicit way to unsubscribe when you no longer need it. But the easiest thing to do is just put a $sign in front of the name of the store, and that will happen automatically for you. And so here is a really simple example. If I go to the next slide here. Okay, here's a really simple example of how you can implement a store and use it from multiple components. So if you look at the display in the lower right, I have one component that is giving me the inputs where you see Mark and Volkmann, and I can type something different in those inputs. And the job of that component is going to be to display the inputs and to make updates to the store if the user types something different in them. And then the part at the bottom where you see Hello Mark Volkmann in large letters, and then there's the clear button, that's my component that I call report. It's in the file report.svelte. And its one job is to display the current data, and its second job is to be able to clear out the data. So let's start from the top in this stores.js file and see how that works. So the first thing I need to do is import a function called writable from the package svelte/store. Then I'm going to create a writable, and all I have to pass to that writable function is the initial value that I want to be in the store. And in my case, I want this to be an object that holds 2 things, a first name and a last name, and they're both starting as empty strings. So I assign that into the variable user, and I'm exporting it so that components can import this. So you see here that a writable can be an object. It can also be a primitive value like a single string or a Boolean or a number. So moving on to my main component, and you see that that's in a file in a directory called routes, and the name of the file is index.svelte. This is actually taking advantage of SvelteKit, which is a framework that sits on top of Svelte and gives a number of advantages like managing page routing for you. And so if I just create that file, that's where I'm going to go if the user types in the URL of my server with nothing after it. It's my default page. So here I have a script tag where I'm importing the user store, pulling it out of stores.js, and I'm also importing my component at the bottom, my report component. So then what I want to render is three things. I've got an input with a placeholder of first name, and then you see that bind :value syntax again, and I'm telling it I want to bind to the first name property that is in the user store. And notice how I'm putting a $sign in front of the name of my store. That's going to make it so I'm automatically subscribed to changes in that store. So if the user types something different in that input, it's going to update the value of the store. Same thing for the last name input. And then finally at the bottom, I'm rendering the report component itself. Then in the last block of code here, that's the implementation of my report component. It is also importing the user store. And I've got that one function clear. So if clear is called, I'm going to create a brand new object with an empty first name and last name and assign that to the user store. Notice again, I have $1 in front of the name of the store. Then down in the HTML for the report component, I'm using an h1 tag to render the current name of this user with their first name and their last name. Again, $sign in front of the name of the store. And then finally, I've got a button where when the button is clicked, I'm going to call the clear function, which is going to clear out the values in the user store. So notice what happens if I do call that clear function. Because the user store changed, that's going to impact the component above it. And those two inputs are going to notice that the value of first name and last name changed, and those inputs will clear out. And so you can see from this very simple example how simple it is to say what data you want to be in a store initially, and how simple it is to import a store and then use it for either displaying data or for making updates to that. And then you see how multiple components can pull in the same store, knowing that if any of them make a change to the store, all the others are going to automatically update. So this is far easier than other mechanisms for managing state that you might have encountered. You might have seen things in Angular like NGRX, or Vue like Vuex, or in the React world using something like Redux. All of those kinds of state management require much more code than you're seeing here. So as a summary of the options available to you in Svelte, you're often needing to get some data from one component to another. And it really boils down to these 6 cases. So first, sometimes a parent component needs to pass data to a direct child, and that is done through props. Props look just like HTML attributes, and so I think we're all used to seeing this way of passing data between components. Another option is that a parent component can pass HTML or other components down to a child, telling it something that it ought to render, and that is done with slots. So the child component can contain any number of slots that can have names associated with them. And then the parent is essentially saying, I'm going to give you some content that you can place into those slots. The third option here is that sometimes you need data to flow in a different direction. Maybe something has happened in a child component and it wants to let the parent know about that. And so for that, it can dispatch an event. Events go from a child up to a parent. And if you want, the event can include data. So the child has a way of passing data back up to its parent. The rarest of these 6 options is the next one. Sometimes an ancestor component has some static data that doesn't change at runtime, and it needs to make it available to descendant components. So if it was a direct child, you could just pass it with props. But what if the parent needs to send it to data that is multiple levels below? There's the parent, then a child, then a grandchild, then a great-grandchild, and it wants to pass it through all of that. So using a context is a way that a parent can say, I want to make this data available in a context, and the context has a name. And then down in some descendant, you can say, I want to grab data from a context with a certain name. So I say that this is rarely used because it's limited to static data. Often the data you want to share is something that can change. And so that makes stores really a better option. And I'll talk about that last. But the next one, number 5, sometimes you want to share data between all the instances of a component. And so on the previous slide, we saw a report component. But what if I use that report component in multiple places within my app, and there's some data that all of the instances of that component want to share, then that's a good use of the module context. We saw an example of that earlier. That's where you have a script tag that has the attribute context set to module. So it's rarely used, but sometimes that's exactly why it's useful, that you want to share data between instances of a component. And then finally, what we looked at on the previous slide is using stores. And this is a great way to share data between components across your app. All the components need to do is import the store, and they can automatically subscribe for changes to that store just by preceding the name of the store with a $sign. And if they make changes, that data is published so that all the other users of that store see it. So that's a good summary, I think, of all the communication options that you have available to you in Svelte. So I hope this was a good review of how reactivity works in Svelte. You have data that's just used inside a single component with plain reactivity, and then we looked at using stores to share data across components. So if you'd like to see more on this, I'm giving a talk next week at the International JavaScript Conference. And if you go to the GitHub repo that you see linked there, there's a directory in the repo called Svelte. And inside that, look for the file svelte-ijs.key.pdf, and you can see the full set of slides that these slides were extracted from. So thank you very much for listening to my talk, and I hope to see you in the future.
All right. Thank you, Mark, for that great overview. Definitely interesting, definitely worth checking out. There is so much more to Svelte. And if you enjoyed the topic, if you enjoyed the talk, other than also obviously going or watching the full talk on the International JavaScript Conference by Mark, you should also check out episode number 2 of the 20-minute JavaScript podcast, where we had a conversation with Mark about Svelte and Svelte Kit as well. So check it out if you found it interesting. And on that note, let me just quickly go back to our slides and get people back here. And we're closing up. So remember that we do this, we plan to do this every month. So stay tuned for our next installment. In the meantime, join our Discord server, or even reach out to us on Twitter. We actively publish technical articles on our blog, and we cover many different topics, Svelte included, but many other JavaScript related and front-end related topics on our podcast, 20-minute JavaScript as well. So make sure to follow us there as well. Before we leave, one final comment: we're hiring. We're looking for Go and JavaScript developers as well as product managers. So if either you like to work with us, or you know someone who might be interested, again, reach out to us on Discord, and we can talk there. Other than that, thank you again, our speakers, and all viewers live here or afterwards watching on the VOD. This is the end. Thank you again, everyone, and I'll be closing it.
Bye, everyone.
Goodbye.
Bye.